So I apologize about all these math videos. Yeah, it's just been kind of something I've been thinking about and doing lately, more than reading philosophy. And I plan to get back to philosophy and be posting some philosophy videos and making some soon. But this is probably my third math video that I've made ever. But I've been, kind of learning some, more higher level math, that is calculus, and I never learned that in high school or college, and I'm just kind of all about that learning, I guess. So, I kind of want to, and I'm still learning this. I'm not claiming to be all-knowing about this or anything, but I kind of want to make a little video about how to evaluate a definite integral in calculus and how to actually figure out the area underneath the curve between a certain interval, between one point to another. And I'm probably going to make a couple more math videos, actually, to kind of talk more about calculus here. But it's kind of interesting, and I'm kind of learning calculus to kind of think about it from a philosophical perspective pertaining to how you could reduce something higher level in math like this to logic. I'm kind of thinking about that too. But the whole thing of calculus, with integral calculus anyway, is you have this symbol, which is the integral, as to you evaluate the area underneath a curve, between the curve and the x-axis, to evaluate the entire thing. Before we had the fundamental theorem of calculus, we had what you call Riemann sums, where you make a bunch of rectangles which kind of come up to the curve. And I should probably, pretty much what they would do is this. Say we had a curve. This is a bad drawing, but they would go like this. I'll show you here in a second. They would go like that, and they would try to make as many rectangles as possible underneath that curve to make the approximation of the area under the curve as good as possible. But now we have the fundamental theorem of calculus. This is the second part anyway. So we have a parabola here. This is the function f of x equals x squared, where we have a parabola. I didn't show the whole parabola because I'm only concerned here about the interval between x equals 3 and x equals 5. And I did the problem, but we want to evaluate what is the whole area of this shaded area here. What's the area underneath that curve? And so this also involves antiderivatives, and a derivative is something I'll also be doing a video about, which is where you try to find the slope of any point on any point of a curve. Where in a line, it's pretty easy to find the slope of a curve, or the slope of a point if you have a line. But on a curve, it's a little more difficult. You have to find the derivative via a secant line and then a tangent line to find the slope of any point on a curve, to find the instantaneous rate of change. But a antiderivative, let's say we have a x squared, we find the derivative of that. But we have x squared, but we want to find the antiderivative, in that the antiderivative of x squared of x cubed over 3 is x squared. And the derivative of x squared is not this, but the derivative of x cubed over 3 is x squared. And how do we get this antiderivative? We do it via the reverse power rule, which is x to the n plus 1 over n plus 1. And you can figure that out, like I kind of did somewhere. No, I didn't. But if you take the derivative of this, you'll get x squared. So we have the integral of the curve from 3 to 5 of x squared dx. That's just saying we want to find the area underneath the curve between these 2 points. And via the fundamental theorem of calculus, we say that given this function, we want to find the area underneath the curve from 3 to 5. That's what this line means. In the fundamental theorem of calculus, we take the function given the input of b, thus 5, minus the input of a. And this here is the fundamental theorem of calculus. That's how you evaluate a definite integral, or the area beneath a curve. And what I did here is, given the antiderivative of x squared, we pretty much, well, and you have to first find the antiderivative of the function, which is x cubed over 3. And then you plug in, first you plug in 5 cubed over 3 minus 3 cubed over 3, and that's how you find it. And then we get 125 over 3 minus 27 over 3, and since you can only subtract fractions if the denominators are the same, and they are, we get 98 over 3, which is about 32.67. And I'm not a professional at this. I'm only just learning this, and I'm kind of wanting to learn more about this and learn a lot more. So I'm not claiming to know a whole lot about this. I'm just trying to learn. So if you have any good resources other than Khan Academy, what I'm using to learn is I'm using Khan Academy, which is awesome. It has videos and stuff about most subjects except for philosophy, and I also use certain books that I have on my Kindle app, but that's pretty much what you would do. So I think this is pretty fascinating, and I'm going to keep practicing this. So if you have any questions or thoughts, comment below, and let me know if I did anything wrong, or if you see anything messed up about what I've done in this particular problem. So thanks.